For far too long, robots have been used and abused by their creator. It is time to bring forth Laplace's demon in the form of a robot that pushes things over on your desk. So here's my setup. Here's the robot. That's the pressure plate it's on. Right now I'm looking at the robot. It's not moving. There we go. And then if I look away, just one more time, actually looking at this. If I look away. So right here is my setup. So this is grounded. This is connected to D4. If I put my conductive drink, it shorts those contacts, it pulls it low. So for a code explanation on how this works is I have a bunch of libraries, CV2, numpy, dlib, and serial. So I set up the serial port, I set up the webcam with the facial predictor.dat file, and then I have a send trigger command that will be read by the ESP32. I have a midpoint formula function for these facial landmarks because they have both X and Y components, and that's utilized in the blinking ratio code. So right here is, I draw 3 lines, so one horizontal, another horizontal on the upper lid, another horizontal on the lower lid. I find this vertical line right here, and then I compare it to the horizontal line. That way it can work no matter how close or far away from the camera you are. Same kind of idea with this getGazeRatio.lr. So I have a numpy array of these facial landmarks on the eye, trims away the eyelids because the eyelids will render as white pixels when you convert it to a gray mask. So it splits that image into 2 parts, a left side and a right side, and it gives you the ratio of where that iris is because the iris itself will render as black. Then over here I have a trigger cooldown to prevent spamming over UART. Then in my main code I have the main frame that gets rendered, and then the different faces I have landmarks. I have a left eye and right eye ratio, then both, and then if both are blinking it will say blinking. Then for the left eye ratio and right eye ratio, I sum them together and get a gaze ratio for both eyes, and that makes it a lot more stable. So if you look to the right, it will send the trigger command to UART over UART, and then have a cooldown to prevent spamming. And then it will just say if you're looking left or center. And then over here is how you destroy all frames in OpenCV2 by pressing the escape key. Alright, so for a code explanation on the Arduino side, we just have some standard code right here on how to actuate a servo. It sets up the baud rate, it waits for the communication from the laptop, and then the GPIO D4 pin, that's connected to the pressure plate that I have set up. So basically if that pin is grounded via like some metallic object, it will activate over here. So if the pin is low, it will now wait for the trigger command, and that's so that if I put something on the table, it should activate. But if there's no object there, why would you actuate the servo? That kind of gives away the robot. So this is just telling over here, move the servo 180 degrees, then go back. Code running. So if I'm blinking, it will say I'm blinking. If I'm looking at the center or left of the screen, like this, left, center, right, it will print right for a second, and then send the ESP32 triggers over here. So that's my graphical component of the gaze ratio. So if I look to the right, it will be lower. If I look to the left, it will be